yes, just a massive thank you to the organizers for, first of all, putting on such a fantastic and frankly inspiring meeting. It's been wonderful to see the faces and to hear where everybody's is at the moment and what they're doing, and it's just been absolutely fantastic. Big thank you to Roz and Patricia and Nasli and Nikki for inviting me and for making it possible for me to be here. So, yes, I'm going to be, I did change the title a little bit. As many people have done, I'm first of all going to speak a little bit about NASSP, and I'm sure you've seen us, so I was part of NASSP at Zero. So the first class in 2003. And I have this man to thank for that, Professor Tony Farrell, sorry, we missed you, Tony, who came to see me in 2002. So I was at that stage teaching high school mathematics, and as well as working part-time at the planetarium running shows. And I only had enough astronomy to basically run planetarium shows. And I'd studied physics, and so he said to me, hey, you know, there's going to be this amazing opportunity, and I jumped at it. So that was a big turning point. So the first MSc class, Laura's here, Bob should be here, and of course there was another Michelle in a class of 5, and then Sadiq as well. And as you can see, we had not yet been upgraded to the better backgrounds at that stage. This is what like a board in your office, Penny, and yes. And so you can tell the OG people from the backgrounds. You need to remember this is before smartphones, so I don't actually have a lot of pictures. But after that, you know, I got my MSc, did a PhD, I bounced around the globe a bit. I have some well-traveled furniture. I was back here in South Africa between 2013 and 2018. And so I've been involved with NASSP in a variety of different ways. And now I'm based in Melbourne. So what has NASSP meant to me? Well, professionally, I have to say that the coursework component, the 3-week crash courses, were pretty hectic, but it was really incredible. So for me, I was just hungry for as much astronomy as I could get my hands on, and having the expert lectures from Manfred, David Walker, Tebby gave us stellar astrophysics, Peter Dunsby, and, you know, thank you to Peter and Penny, who really just, you guys were absolutely amazing. And the fact that you spearheaded this was, you know, just incredible, obviously with strong help from Patricia. So I look back fondly now on those days, but you know, it really gave a lot of momentum, and I still, you know, look back at those lectures. It was really just an incredible thing to have access to experts on that. Obviously, there's the research experience, which allows you to decide to PhD or not to PhD, a decision you should not make drinking with Retta Pretorius at the UCT club, as it turns out. And then there's the NASSP community, and I think the thing that I really picked up from yesterday is it's not just a network, it's really a family. And, you know, are we actually tapping into that enough? And that's something I'm going to speak about a little bit later. But even back in those days, NASSP really lowered the barrier in terms of interacting with the astronomy community, and that was incredibly valuable. So just having that, you know, pathway to speak to people about their research, it's just, you know, really ahead of its time, frankly. And then now we have this network of collaborators and alumni. I'll be speaking about some of them a little later. And then, as I mentioned, you know, I've had various roles with NASSP, as well as being, you know, one of the first classes. So just on a personal note, this was definitely a key turning point in my life, and if you give me just one glass of wine, I will tell you all about it. But it really was an opportunity that led to so many other opportunities, and I'm sure all of you have experienced that. So the doors that opened as a result of NASSP. And obviously it allowed me to explore a career in astronomy, which I didn't think was possible at that stage. And then also to see the other possibilities. And it's been really fantastic to hear from the people who've gone on to do other things And that's not only inspiring, but it's also something we should, again, be tapping into and using these connections to provide these pathways for people to, go and do other things. And of course, there's the experiences. The SAO Bries are legendary, but, the summer schools and all of those. But really, it was all about the people. And so this is from the year that I organized the summer school. And so many of these people you will recognize, not Rudy, but he's over there. Right, so just a little bit about my current research, and if any of this is interesting to anybody, if you don't catch me today, I'm flying back tomorrow morning, then please drop me an email or speak to some of the other people that are in close contact with me that are here. So I spend a lot of time looking at the mid-infrared properties of nearby galaxies, using particularly the WISE mid-infrared telescope, looking at star formation using WISE. I also got involved in large redshift surveys, which I'll speak about more in a minute, and I'm particularly interested in the role of environment in the nearby universe. And I work a lot in the multi-wavelength space. So this is a nearby galaxy with WISE. WISE was not a very big space telescope, but it did survey the entire sky. And so you might be looking at that going, well, that is not a very pretty picture of a galaxy. And yes, especially when you compare it to the other mid-infrared telescope that everybody talks about now. But you know what? This is actually too much detail. This image hurts my brain. I will quite happily work with the fuzzy images. I have no idea what's going on there. Anyway, I'm happy. So one of the things I'm currently working on is a benchmark of nearby galaxies in the nearby universe, using mid-infrared data, using, in fact, the S4G data set, which was PI'd by Kartik Sheth, who is someone that has been connected to NASSP, and in fact, I believe will be, is currently working towards developing closer partnerships with South Africa, which is something I will watch closely. As I said, I'm really interested in the role of environment, so I lead a project called MEERHOGS, which is the Meerkat Habitat of Galaxies survey. So we're incorporating redshifts, mid-infrared data, giving us star formation and stellar mass, and then H1 and radio continuum from Meerkat. And this is a very exciting project, so watch this space for things happening there. Also, one of the things that I'm focusing on, so 4HS, which I'm about to tell you about, one of the things we need to work on is group finding when we have uneven completeness in our data sets. And so this is work that my PhD student is currently doing in Australia. Incidentally, he's South African. And we are using the group finder that Tristan Lambert, an ex-NASSP student, wrote. So that's some work we're doing there to, again, establish a benchmark of environment, so we can first of all decide where we should be focusing our H1 and radio continuum observations, but also to have a baseline to compare, to look for influences of environment. Okay, so the Southern Hemisphere is about to undergo an absolutely exhilarating period of change, which is also incredibly terrifying. And I wish I was 20 years younger, but I'm not, so it's going to basically be handed over to a lot of the young people that I'm looking at the moment. We're going to have these amazing facilities starting up, many of which we've already heard from. So LSST, Renee will also be speaking about that later today, but Michelle spoke about it yesterday. SKA, I'll be telling you a little bit more about Foremost. There's also eROSITA with the X-rays. There's Euclid, near-infrared, covering large areas of the sky. And then, of course, there are high-energy facilities as well. So the Southern Hemisphere, which has always lagged behind in terms of coverage for redshifts and imaging, is about to drink from the fire hose. And we're going to have quite a time processing and understanding all the data that we're about to get. So one part of that is the Foremost project. So the VISTA telescope at Paranal was a near-infrared imager, And what they're doing is spending a whole lot of money to convert it to a multiplex, multi-object spectroscopy. Did I do something wrong? There it is, great. Facility. So there are 2,500 fibers, more or less, optical fibers. So 2 low-resolution spectrographs. They're actually more medium resolution. 1 high-resolution spectrograph. So this is a machine for spectroscopy. And this is the really amazing positioner that is kind of the secret sauce. So that should change. So you can see that reconfiguration is basically instantaneous. And so, this facility will be taking millions of spectra over a 5-year period. So it's great having 2,400 fibers, but there's actually no way to efficiently occupy them if you're just a single survey. So it's a very different model with Foremost. We actually pool all our objects together. So we have galactic and extragalactic surveys, and they are then commensally observed. So we actually share the focal plane. And this is actually something that, well, it's pretty challenging, but it's actually very exciting as well. So there originally were 5 galactic and 5 extragalactic consortium surveys. Really, Foremost is a Gaia follow-up. First and foremost, no pun intended, and then Erisita follow-up, and then there's also cosmology and galaxy evolution. So as part of the agreement with ESO, community surveys, a certain amount of time was set aside for community surveys, and so there were 6 galactic and 9 extragalactic community surveys that joined in 2022, and I co-PI the Foremost Hemisphere survey with Edward Taylor, who's also at Swinburne. And what we're going to do is very ambitious, but we're taking full advantage of this very different operations model. What we're aiming to do is get spectroscopy and redshifts for about 6 million galaxies, covering essentially as much of the southern sky as we can, with high and unbiased completeness so nearby universe means different things to different people, but roundabout redshift of 0.1. So there are 3 main science goals: mass and motion. So we're going to map the southern sky. This has never been done to these kinds of depths. We use peculiar velocities to give us the motions. And so we'll basically have this incredible map that we can use to test and measure gravity. Then there's also galaxy demographics as a function of galaxy environment, which is something very close to my heart. And so we're going to have the best possible description of environment, local and large scale, and with what Ned likes to say, overwhelming statistics. Well, I find all statistics overwhelming, frankly, but we'll be in a position to have the best possible description of these things to actually be able to disentangle how environment is, preceding or influencing galaxy evolution. And then there's the, just as the legacy value in support of all these other facilities. And so I'll just touch on that very briefly. So first of all, 4HS with H1 surveys, it's incredibly powerful as a probe of the baryon cycle, so how gas is being converted into stars. Then in terms of LSST and various other surveys, people much smarter than I am will do weak lensing. And then there's a very key, so we heard from Michelle yesterday, the time domain is about to really take off. Well, it's already, incredible what's happening at the moment in the transient space. So we really hope to be providing, certainly out to redshift of 0.15, the hosts and counterparts for a lot of the events that are going to be picked up by, in particular, LSST. So this is who we are. I just want to point out there are a couple of people affiliated or here in South Africa. So Ilani and Lucia and Roz and Moses actually have very key roles within 4HS. So please feel free to contact them if you don't want to contact me. But please, if this is something that interests you, This is, we will have far too much data and far too much science. So please reach out if this is something you want to be involved with. So this is what we're hoping to do. So it's actually great looking at our input catalog. You can already see the large-scale structure. Renee, you can see we're pushing as far as we can into the zone of avoidance where all the good stuff is. This is what we hope to transform this into a three-dimensional map as by 2030. We had to reprocess all of the VISTA near-infrared imaging for our input catalog. This will all be made publicly available. We also have photometry, so they will be through Data Central in Australia. We will release this for people to use. So this should happen within the next year. Although I'm aware Roz will know I've been saying that for a year, but seriously, soon it will be available for people to use. And you're looking at something that's significantly deeper than 2MASS. This is a completely underutilized and amazing resource. So that VHS imaging will be made available. So this combination of facilities, I am a multi-wavelength person, so I'm just very excited by the sorts of science we'll be able to do. And as Moses mentioned yesterday, the baryon cycle, I think that this is really, an incredibly, 4HS in combination with these facilities is going to be an incredibly powerful probe of the baryon cycle, which I think is really sort of the frontier that we need to solve if we're going to make progress in terms of understanding galaxy evolution. So just my last two slides. So I think that in the past 10 years, we've become really good in terms of combining our multi-wavelength data sets with cosmological simulations and making really incredible strides in terms of our understanding of galaxy formation and evolution. But as part of Foremost, and especially sharing the focal plane with so-called galactic astronomers, I feel like these lines are blurring a lot. And I've become to appreciate that if we're going to understand how galaxies form and evolve, we actually need to first understand how our own galaxy has done this, and how galaxies very near to our own galaxy are part of that process. And so I think that this is incredibly exciting to be working far closer with these two communities. And I think South Africa is really well poised actually to start to blur these lines as we start working with these incredible data sets. This is my last slide. We are going to have an incredible challenge, not just with the data, which is something that we've been speaking about for quite some time, but how we actually convert that into knowledge. And I think that the fact that we have so many alumni who are working in the data science space really speaks to strong partnerships, because I think how we get knowledge using tools like machine learning and statistics and that sort of thing, I think is really something we should be thinking about. If AI is going to be writing our papers, is it also going to be reading our papers? How are we actually going to be disseminating knowledge when it's just going to be drinking from the fire hose? These are things we should be thinking about now. So I'm really excited about the idea that we should be using this network to build partnerships. One thing I will say is that, something like 4HS will give us data on complex populations that you can slice and dice and train on and do all sorts of things on without any ethics approval, right? Nobody's going to die on the table. So let's work together, use our data sets to help inform the sorts of things that you are doing. So yes, everyone should be very excited about and jealous of the data that astronomers will have, but we just can't go at it alone. I think South Africa is just ideally positioned to leverage not just the Southern Sky advantage that we've always had, but we're hosting a major facility. We already have Meerkat, and we have strong involvement in things like LSST and then Foremost as well. And I just can't imagine that NASSP doesn't have a key role to play in this, especially given the people in this room and the people that are online and this network that's been built up. So thank you very much.